This is Apollo Saturn Launch Control. We're at T-minus 6 minutes to the first manned mission to the moon. When Neil Armstrong took that first historic step onto the lunar surface, the world was gripped by awe. The US had won the space race, and what a victory it was. After Apollo 11, NASA sent a handful of astronauts to explore the moon, but the program ended abruptly. It's been over 50 years, and no human has returned. Why has NASA not revisited the moon despite the advances in technology and science? In this video, we'll explore the reasons behind NASA's long hiatus from moon missions and what lies ahead. The Moonwalking Club is incredibly exclusive, with just 12 members. Of those, only 4 are still alive today. Neil Armstrong was the first to step on the lunar surface, and Eugene Cernan, who left in 1972, was the last. Back then, no one could have guessed that we'd stay away for so long. With all our scientific advancements, a return seemed inevitable, yet it never happened. Why? Let's start by going back to the 1950s, when the world was a different place. Countries and territories that once existed have changed dramatically. But the space industry, too, is barely recognizable from those early days. The Cold War was in full swing, and the rivalry between the United States and the Soviet Union extended into the cosmos. The space race became a matter of national pride and technological superiority, and both superpowers were determined to outdo each other. This fierce competition began in earnest on October 4, 1957, when the Soviet Union launched Sputnik, the world's first artificial satellite. Sputnik's success shocked Americans, who saw space as the next frontier, a place where American values and exploration spirit should triumph. Sputnik also demonstrated the Soviets' missile capabilities, which made it clear that the US needed to act quickly. In response, the United States launched its first satellite, Explorer 1, in 1958, and President Dwight D. Eisenhower established NASA to lead the charge in space exploration. The space race was heating up, and both sides were determined to prove their technological prowess. The Soviets, however, maintained their momentum. In 1959, they launched Luna 2, the first probe to reach the moon. And 2 years later, in 1961, Yuri Gagarin became the first human to orbit the Earth. The United States wasn't far behind, with astronaut Alan Shepard making a suborbital flight in May of 1961. That same month, President John F. Kennedy set the ambitious goal of landing a man on the moon before the end of the decade. It was a bold challenge, one that would push American ingenuity and resolve to its limits. NASA's Apollo program was born out of this drive to win. With a massive budget increase and a team of 34,000 employees and 375,000 contractors, Apollo represented one of the most significant endeavors in human history. Despite setbacks like the tragic loss of 3 astronauts in a 1967 launch simulation, the program continued with determination and grit. Apollo 8 orbited the moon in 1968, and just 1 year later, Apollo 11 made its historic landing. Neil Armstrong's famous words, "That's one small step for man, one giant leap for mankind," marked a pinnacle moment. America had taken the prize, the Soviets had failed in multiple attempts, and the space race had its winner. But after the triumphs of the Apollo missions, the enthusiasm began to wane. The moon seemed less tantalizing now that the race was over, and attention turned elsewhere. NASA faced new challenges, and funding became a recurring issue. The agency's budget, which had peaked in the 1960s, declined sharply. In the 1960s, NASA's budget was nearly 4% of the federal budget. Today, it sits at just 0.4%. Such cuts make it incredibly challenging to finance manned lunar missions, which are notoriously expensive. Returning to the moon could cost upwards of $162 billion, a daunting figure by any measure. But funding isn't the only hurdle. Politics plays a significant role in the fate of NASA's projects. The process of designing, engineering, and testing a spacecraft capable of sending humans to another celestial body takes years, often outlasting presidential terms. As new administrations come in, they bring their own priorities, often canceling previous projects. This constant shifting in direction has led to delays and wasted resources, further complicating NASA's ability to return to the moon. Adding to these challenges is the reality of lunar exploration itself. The moon is a rugged and unforgiving environment. Its surface is pocked with craters, covered with sharp rocks, and blanketed by a layer of fine dust called regolith. This dust is not like the sand on Earth. It's composed of jagged, microscopic glass-like particles that can damage spacesuits, equipment, and machinery. During the Apollo missions, astronauts found that the dust clung to everything, clogging joints and seals, and even causing lunar hay fever. Overcoming these hazards is no small feat, and requires robust engineering solutions. Then there's the issue of radiation. Unlike Earth, the moon has no atmosphere or magnetic field to protect against cosmic rays and solar radiation. Any mission planning a long-term stay will need to address how to shield astronauts from this constant bombardment, which increases the risk of cancer and other health issues. Current research is looking into building lunar habitats underground or using specialized materials that could block radiation effectively. There is also the ongoing concern of life support systems. Any human mission to the moon requires reliable, sustainable life support systems capable of maintaining oxygen levels, removing carbon dioxide, providing clean water, and controlling temperatures in the extreme lunar environment. Innovations are underway, but developing technologies that can operate flawlessly over long durations in such a hostile setting is a monumental challenge. So, why hasn't NASA returned to the moon? Money, politics, environmental challenges, all are factors. But there's another element at play: the changing landscape of space exploration itself. The emergence of private companies, such as SpaceX, Blue Origin, and others, has revolutionized the way we think about space travel. These companies are developing new technologies, like reusable rockets, which could dramatically lower costs and increase the frequency of missions. NASA recognizes this shift and has begun partnering with these firms to achieve mutual goals. The Artemis program, which aims to land humans on the moon by 2025, will rely heavily on these private sector partnerships. Looking ahead, NASA is not only planning to land on the moon, but to stay. The goal of the Artemis program is to establish a sustainable human presence on the lunar surface by the end of this decade. This will involve building a base camp at the moon's south pole, where water ice deposits could be used to provide drinking water, breathable air, and even rocket fuel. A sustainable presence on the moon could serve as a stepping stone for more ambitious missions, like sending humans to Mars. The moon, once seen as the ultimate destination, is now considered a proving ground for technologies that will take humanity further into the cosmos. The Artemis missions will test the new Orion spacecraft and space launch system, along with other cutting-edge technologies like lunar habitats, rovers, and power systems. The lessons learned will be critical, paving the way for the next great leap, a journey to Mars. In conclusion, the reasons for not returning to the moon are many and complex, ranging from budget constraints and political shifts to the inherent dangers of lunar exploration. But there's a renewed sense of purpose now, a shared ambition among NASA and its partners to push the boundaries once again. Will we see astronauts back on the moon soon? The stage is set, but only time will tell. In the meantime, if you enjoyed this video, please give it a thumbs up, and don't forget to subscribe to Historical Highway for more content like this. Your support means the world to us.